Hello everyone, we'll start our 6.4 today, and we have question number 1. Let triangle ABC similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square. If EF equal to 15.4 centimeter, find BC. Okay, so the condition given in the question is triangle ABC is similar to triangle DEF, and for both the triangles we have got the areas are given, and even EF is how much? 15.4 centimeter, and we're going to find BC. Okay, we'll start a solution here. Solution. First I'll write given. In given we have to write triangle ABC similar to triangle DEF. Okay, next what do you have to write? We have to write area of triangle ABC. AR, area, then triangle ABC is how much? 64 centimeter square. Next I'm going to write area of triangle DEF. So area of triangle DEF is how much? We have 121 centimeter square. 121 centimeter square. And at the last we have EF. EF is how much? This is 15.4 centimeter. Next I'll write to find. To find. We have to find what? The length of BC. Okay, next I'll start the procedure. In procedure what happened? First let me write triangle ABC similar to triangle DEF. This is given by the question, so let me just write here given. Okay, below this what happened? We know that as the two triangles are similar, we can write in this way. Let's see. Area of triangle ABC divided by area of triangle DEF. Here I can write BC by EF whole square. This is from the theorem 6.6 that we studied in the last class. Okay, now I'm going to write here what is the area of triangle ABC? 64 centimeter square. So let me just write here 64. And what about DEF? 121. Then equal to, I don't know, BC. And what about EF? EF is 15.4. So 15.4. Then whole square. Okay, let me drag the screen. Yeah, next. This square, let me bring to the left hand side. So how shall we get now? It will be converted into square root over. So square root over 64 by 121. Okay, then equal to, then BC divided by 15.4. okay, so this 64 and 121, what happened? 64 is 8 square, and what about 121? 121 is 11 square. So both 64 and 121 are perfect squares. So I can write here 8 divided by 11, because root over 64 means definitely you can write 8 square. So square and root cancel, so we get here 8. Similarly, even we can write 4 root over 121 as well. So I can write here BC divided by 15.4. So let me perform the cross multiplication. 11 into BC, so 11 into BC. Then here 8 into 15.4. Okay, next what we will do, we'll be writing here BC, then equal to how much? This is 8 into then 15.4, and then here 11. Now see properly, let me cancel 15.4 and 11. 11 1 is 11, 11 1 11, then there should be definitely point. Okay, now 44, 11 4 44. So here how much? BC is 8 into 1.4, 8 4 32. We have get it 3 in hand. 8 1 is 8, 11. So after the point we have only one digit. 1.4 means after the point we have only one digit, so I need to put the point before 2 here. Okay, so what is the length of BC now? BC is 11.2 centimeter. So of course this is centimeter. So you can give the conclusion here. Therefore BC is what? 11.2 centimeter. Now we have question number 2. Diagonals of a trapezium ABCD with AB parallel DC intersect each other at the point O. If AB is 2 times of CD, find the ratio of the areas of triangles AOB and COD. Okay, let's see now. We have a trapezium here. In that trapezium, what happened? AB is parallel to DC. Okay, let's draw now. Okay, we have seen the trapezium here, and what happened now? I'll give here A, I'll give here B, I'll give here C, and I'll give here D. The question tells that AB is parallel to DC, so this AB is parallel to DC. Okay, and the diagonals intersect each other at the point O. So first let me draw the diagonal AC, next diagonal BD. These two diagonals intersect at the point where? O, according to the question. And AB is what? 2 times of CD. Now we are going to find the ratio of the areas of triangle AOB and COD. Okay, so first let me write solution. I'll write given here. Given. In given, what we are going to write? I'll write ABCD is a trapezium. Next, I can write here what happened? AB parallel DC. Okay, then I'll write next diagonals AC and BD intersect where? Intersect at O. And at the last I'll write AB is 2 times of CD. That is the given. Okay, next what we have to prove? Sorry, it's not to prove, we are going to find. I'll write here to find. We have to find the ratio of areas of triangle AOB and COD. So area of AOB by area of COD. This is what we are going to find. We have to find the ratio. Here I'll write procedure. Okay, let me drag the screen on the left hand side. So first let's see where is triangle AOB. Here we have triangle AOB. This is our AOB. And what about COD? This is your COD. Okay, so how can we prove that these two triangles are similar? Okay, we can prove like this. This angle and this angle, they are equal because they are alternate angle. As the question tells you that DC and AB are parallel, so if I draw in this way, what happened? This angle and this angle, they are alternate, and as the lines are parallel, definitely if it is, let me say 45 degree, then even this will be 45 degree. Okay, next we have this one again. This angle D, and this angle B. I mean CDO and ABO. These two angles are again equal because alternate angles. That's how we're going to prove that triangle AOB and COD are similar. By what similarity? By AA similarity. I'll write here in triangles. The first one is AOB. AOB. And what is the next triangle? COD. COD. First I'll write angle OAB. This is OAB. Will be equal to what? Angle OCD. This angle. You will write here alternate angles. Next, let me write angle OBA. OBA will be equal to what? Angle ODC. ODC. Here the same reason we have to give. Okay, so therefore triangle AOB is similar to triangle COD. So what is the rule here? You have to write here, but for me there is no space, so I'll just write here. What is that? By AA similarity. Okay, now we have proved that these two triangles AOB and COD are similar. Then if two triangles are similar, what happened then? I can write in this way. Okay, let's see now. Therefore, area of triangle AOB divided by area of triangle COD. Here you can write AB. AB means what is the corresponding side of AB? CD. Then whole square. Okay, now I'll write here equal to. The question tells you that AB is what? 2 times of CD. This is given by the question. Okay, so what happened now? In place of this AB, let me write twice CD. Twice CD. Below this, I'm going to write CD again. Then here whole square. Okay, now you can cancel CD, CD. So what happened now? We have here 2 by 1 whole square. So this is nothing but 4 by 1. So in the form of ratio, you can write equal to 4:1. We have question number 3. In figure 6.50, ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, so that area of triangle ABC by area of triangle DBC equal to what? AO by DO. Okay, so first, where is triangle ABC? We'll see now. ABC. ABC. This triangle. And what about DBC? DBC. DBC. Okay, these are the two triangles formed on the same base. What is the same base? BC. And we have seen that here AD intersects BC. AD intersects this BC where? At O. Now we're going to show that area of triangle ABC by area of triangle DBC equal to AO by DO. I'll write solution here. Okay, first given. What shall we write in the given? I'll write here ABC and DBC are two triangles on the same base BC. And then here AD intersects BC at O. And next, what do you have to write? We have to write to prove prove? We have to prove that area of triangle ABC by area of triangle DBC is what? AO by DO. This is what we're going to prove. Okay, so next we have construction. So how we're going to construct, let's see now. I'll write here construction. Okay, in construction what we're going to do is, from A I need to draw a perpendicular on BC. Let me draw here. Let me use the red color. Okay, fine. From A I'm going to draw the perpendicular on BC. This is what? 90 degree. And here I'll just write here M. AM is perpendicular to what? BC. Like that, from D on this BC, let me draw a perpendicular. And here I'll give N. Here AM is perpendicular to BC and DN is perpendicular to BC. So what we are going to write in the construction, I'll write here draw. What I draw AM perpendicular to BC. And what about next? DN perpendicular to BC. Yeah, I have done till the construction. Next we have procedure. In procedure, what we are going to write? First, I want to prove that this triangle AOM and DON, they are similar. First, let me write in triangles AOM and DON. Let me prove that these two triangles are similar. Okay, how can you prove? I'll continue here. After this, I'll continue here. Okay, so below this I can write here angle AMO. AMO equal to what? You can write DNO. Angle DNO. Okay, why? Because in the construction what happened, AM is perpendicular to BC and even DN is perpendicular to BC. So you can write here by construction. By construction. Next, I can write here angle AOM. AOM equal to what? Angle DON. DON. Why are they equal? Because vertically opposite angles. Okay, let's see here. I drew a line here. Let me draw a line here. So this angle and this angle, they are equal because vertically opposite angles. So similar situation, condition takes place here, and I'm going to write here vertically opposite angles. Okay, therefore what happened? I can write triangle AOM is similar to triangle, what is that? DON. Yeah, we have done this. So below that, what I can write? I can write here. Here I'm going to write AA similarity rule. Okay, so what happened now? Here I can write AO by DO equal to what? AM by DN, and here I'll give equation 1. Now, okay, let's find here. Here I'm going to write area of, therefore area of triangle ABC divided by area of triangle DBC equal to what? Let's apply the formula here. 1 by 2 half into base into height. Okay, for the triangle ABC, AM is perpendicular to the side BC. Therefore, this BC will be taken as the base and AM will be taken as the height. So I'll write here BC into what? AM. And below that I can write again 1 by 2 into the same base BC will be taken. And what is the perpendicular on BC? DN is perpendicular to BC. So this DC will be taken as the height. So I'm going to cancel now half, half, BC, BC. Then what do we have now? We have here AM by DC. Okay, look at equation 1. In equation 1, AO by DO equal to AM by DN. Sorry, this should be DN. Here DN is perpendicular to what? BC. So it should be DN and here DN. Okay, now in place of this AM by DN, what I'm going to write? I'm going to write AO by DO. Okay, so we'll write here AO by DO. And you can write here from 1. So below this, let me write hence proof.